first degree price discrimination, second degree price discrimination, and third degree price discrimination. So why don't we go to our notes and see if we can find that, since this is one we need to look up. So let's see. Here's our notes. Now let's see if we can find third degree price discrimination and see if it makes sense in this context. Here's my cost, market structure. No, it's for this. Before costs.
Good evening.
Good evening. Ooh. Okay. Okay. See what I mean? But looking up answers takes so long. We're still on consumer choice, elasticity. Where's price discrimination? Consumer choice. Elasticity was the first thing we covered. So it's consumer choice. It was prices. All right, so we need to find what do we do with prices? Consumer choice, a difference curve, tangency, costs, market structure. Okay, here's the pricing. So we're looking for markup, pricing, price discrimination. And here's the price discrimination. Let me open it a bit wider. Okay. So third degree price discrimination says charging different prices to different market segments for which the costs are identical. Second degree price discrimination says quantity discounts. A firm charges a lower price per unit so that buyers buy a larger quantity. Doesn't that sound like our question? Let me go back to our question. Okay. Here's our question. In an ideal world, I'd like to offer lower prices to those willing to buy in bulk. That's second degree price discrimination. That's not third degree. So the answer would have to be none of the above. See, third degree price discrimination looks nice, like it might be the right answer, but then when you go to your notes, and we look at the actual definition, third degree price discrimination only says charging different prices to different market segments, like airlines, concert, movie tickets, and sports stadiums. But our question talks about buying in bulk, you know, sort of Sam's Club, Price Club kind of situation. And that is second degree price discrimination. Okay. All right, let's see if this one's a little easier. So far, none of these multiple choice questions have been easy. And that shouldn't come as any surprise to you. They're not going to be easy tomorrow either. So a consumer will optimize his or her consumption by A, bypassing consuming on a lower indifference curve if there's a higher, more affordable one. B, consuming on the highest affordable indifference curve. C, consuming where the indifference curve is tangent to the budget line. D, maximizing marginal utility and total utility. And E, all of the above. Now, is there any that we can eliminate?
D.
Maximizing marginal and total utility?
Isn't that looking at it from the company's perspective?
No, what's marginal utility? Marginal utility is the extra satisfaction that you as a consumer get from the purchasing and consuming of another good. So we're still talking about consumers.
It sounds like the answer would be all of the above.
Okay, all right, so let's see. A consumer will optimize his or her consumption by bypassing consuming on a low indifference curve if there's a higher, more affordable one. Does that make sense?
Yes, it does.
So we think A is true. Let's see, let's go back to our notes. So here's our notes, and let's see if we can find a difference curves thing. Okay, here's our indifference curve thing. And if you recall, if you look at this point T, right? We said we would not consume at point T because we can afford to consume. Okay, that's
Someone mic on?
Yeah, I don't know if that's Wesley or Latier. That's very loud. The question though is that would we consume on the indifference curve marked by point T? We wouldn't, because we said we can afford to consume on a higher indifference curve, right? Because we said, if we said our budget line was CD, we could afford to consume at T, but we can also afford to consume at U. And since U gives us more satisfaction than T, we would always want to go with the highest affordable indifference curve. So we're quite correct in that. Go back to A is certainly true. We would bypass consuming a lower indifference curve if there's a higher, more affordable one. But we don't want to automatically choose A because there's E that says all of the above might be possible. You see? Because even though A is true, A may not be the correct answer if both B, C, and D are also true. In that case, E would be the correct answer. So we have to look at the rest to see if they're also true. Is it true that we would always want to consume on the highest affordable indifference curve?
Yes, that's true.
Because they're not saying on the highest indifference curve, they're saying the highest affordable indifference curve. So if A is true and B is true, then the answer is supposed to be E. But just in case, because it is possible that we may thought A and B are true when one of them might not be true. Let's look at C and D just to make sure. Do we consume where the indifference curve is tangent to the budget line? Here's our notes. Look at U, look at V, look at W. In each of those cases, we see that the indifference curve is tangent to the budget line. We don't consume anywhere else on those indifference curves. We only consume where those indifference curves just touches or tangent to the budget line. So yes, it is true that we would consume where the indifference curve is tangent to the budget line. So if that's the case, and if we're pretty sure at least two of those three are true, then all of them must be true, even if we're not sure about D. Because if we're sure about A and we're sure about B, then the answer has to be all of the above. Or if we're sure of B and we're sure of C, then the answer still has to be all of the above. And in fact, the answer is all of the above. Oops, sorry, went too far. Question 8. How do we define marginal profit? Is it the additional profit achieved from producing and selling one more unit? The additional revenue achieved from producing and selling one more unit? Producing at a point where revenue is equal to marginal cost? Subtracting economic cost from total revenue, or none of the above?
The answer is A.
I think this one is a giveaway. Marginal profit is the additional profit achieved from producing and selling one more unit. Question 9. Regardless of the market structure, so it doesn't matter what kind of market structure you are, a firm should always seek to the additional profit achieved from producing and selling one more unit, additional revenue achieved from producing and selling one more unit, produce at a point where revenue is equal to marginal cost. Oh, there's an error here. It doesn't make a difference to question 8, but it does make a difference to question 9. That should be marginal revenue and of course, I've given away the answer. Regardless of the market structure, a firm should always produce at a point where marginal revenue is equal to marginal cost. Always. Regardless of the type of company it is, you'd always produce where marginal revenue is equal to marginal cost, because that's where your production is at its most efficient. All right, and question 10, which I think is also a giveaway. All right. You have an elasticity of negative 0.33333. Because it's elasticity of demand, we can ignore the negative sign. So the question is this demand elastic, inelastic, or unilastic?
Inelastic.
Because it's less than 1. We're ignoring the negative sign. Fine. Does that help us in answering the question? Did you guys have a question similar to this for your midterm or something? All right, fine. If your demand for your concert tickets are inelastic and you want to make more money, do you give up because nothing you can do? Do you raise your price, lower your price, offer a discount, or all of the above?
Offer a discount.
Why? I'm curious. I'm not saying you're wrong. I just want to know what you're thinking. What's the relationship between elasticity and revenue? We know we've defined elasticity as how sensitive or responsive people are to our change in price. All right. How quickly, how strongly they react when we change our price. And we've said the greater the elasticity, or the larger the elasticity, the more responsive people are. And the more inelastic demand is, the less responsive they are to a change in the price. For an elastic demand, if we change our price, if we raise our price slightly, we lose a ton of customers, because customers are very sensitive or very responsive, or very responsive to a change in the price level. But for inelastic demand, which applies for a lot of things that you have to buy, necessities, utilities, etc., a change in the price doesn't engender that strong reaction as before, because you don't really have a lot of choice. Hence, your demand for this product is inelastic. That means that if demand is inelastic, this is such a sweet concert that if we raise our ticket prices, we're not going to lose a ton of customers. It also means that if we lower our ticket prices, we're not going to get a ton of extra customers, which probably means if you have in this case, constant ticket demand or inelastic, it probably means that, this is such a hot ticket that you're pretty much already sold out. So lowering the price and offering a discount is the exact same thing. Offering discount is just lowering the price for a couple of people, but it's still lowering the price. But lowering the price is not likely to get you a bunch of extra customers because demand is already inelastic. Or am I explaining too much?
No, you could continue.
Bottom line is, things to make note of. If demand is inelastic, raising your price will make you more money because people don't have a choice. If demand is inelastic, that means they're insensitive or unresponsive when you raise the price. If demand is elastic, that means they're very sensitive, very responsive, so you can't raise your price, but they will react very quickly to a discount or a sale. So, elastic demand, lower the price. Inelastic demand, raise your price. In this case, we have inelastic demand, so the answer would be B, we would raise our price. Because we've done such a great job of marketing, everybody wants to get into our door. So you know what we do? You know what, in this case, what will happen? This is people who show up at the door pay a much higher price to get in than people who buy their tickets ahead of time. That's all this is. That's all this is. Raising the price, in this case, would just be, I charge a higher price at the door. Okay. We've done our elasticity calculations already. And what's our next section? Producer and consumer surplus. All right, fine. First question. When you see a question like this, in your mind, do you have enough information looking at this question to do producer and consumer surplus? Does it look like you have enough information? The market price for Asti Spumante sparkling wine is $75 a bottle. And at this price, 201 bottles are demanded and sold. James is willing to pay as much as $225 for a bottle, and the Base Road Bar is willing to sell a bottle for as little as $15. Can we calculate the consumer surplus for James? We don't have any diagrams to work with. But you have diagrams in your notes. So let's see. Here's our notes. I don't know if consumer surplus is before or after this. Probably after. Oh, here it is.
Yeah, we do have enough information.
So let's assume that even though you don't have this diagram, you have this diagram in your head, right? Or you sketch it quick on a little piece of paper if you need help sort of visualizing it. So we said James, if we're doing consumer surplus first, I'm looking for consumer surplus for James. All right, let me pull back up our question. The market price for Asti Spumante is $75. So if we go back to our thingy, all right. So we know it said where it said P of 10, we know this is supposed to be, sorry, where it says P10, it's actually P75 because we said the market price for this wine is $75. Right? And we said James is willing to pay how much? 225. Right? The market price is 75. James is willing to pay 225. So what is his consumer surplus?
150.
I don't know. Let's see. Consumer surplus of James is equal to its price times quantity, right? P times Q. Space 75. What's the difference between 225 and 75? 150, you said?
Yeah.
So he saves 150 and he's only buying one bottle. So his consumer surplus is $150. Yes? Let's go back to our notes. So he bought one bottle, and the difference between his 225 and 75 is 150. So this area A, in this case for James, would be the length or the height, which is the 150 times the one bottle that he bought. 150 times 1. Now, question is asking us, let's go back to here. It's asking us for consumer surplus for the entire market, including James. So let me go back to the notes. So this is James, James is A, and the rest of the market is B, but they're asking us for the whole thing, A and B. So we already did James, so we need to find the rest of the market, which is B, and then add the two together. This is when it's going to be important to you to make sure you read the question carefully and not read what you think the question is saying. So let's go back to the question, just to make sure. And if you notice, the question does in fact say, calculate the consumer surplus for the entire market, including James. So we already have James' piece. So consumer surplus for James, yes, is 150. Right? So we know that part of it. Now we need the consumer surplus for everybody else, and then we add everything together. Right? All right. So what about the rest of the market? Consumer surplus for rest of the market.
So we subtract 1 from the 201.
Yes.
And we get 200.
Very key point. All right, let's go back to our notes just to make sure.
One would be James.
So now we're looking for the rest of the market. So we're looking for this B. So this triangle area, because we already found the area for the A, this triangle area you see goes from 1 to 75. Or in our case, this was 201. So it goes from 1 to 201. So it's 200. So we need to find this area B, that's the area of a triangle. And the area of a triangle is what?
Half the base times the height.
Okay, so it's 1/2 B times H. All right. And now we just want to make sure we plugged in everything right. That's 1/2, and we said, now the base we said is 200, right? But it's 1/2 of 200 times the height we said was what, 150? tab, equals 100 times 150. I need a small x. What's 100 times 150?
15,000.
150.
Okay, y'all need to make up your mind.
It's 15,000.
15,000. Okay. Therefore,
Oh, sorry. I
total consumer surplus, right, equals
15,000 plus
150.
150.
Okay, you could do it that way too. But since James came first, I just put him first, but it works fine. Now, 15,000, 150. All right. If that's the case, then can we do the same thing for the producer surplus? All right, we have the base road bar. Let's go back to our notes. So we're looking for producer surplus. Here's producer surplus. The base road bar we said is the A. The rest of the market is the B. According to the question, the base road bar is willing to sell a bottle for $15. But what's the market price?
75.
Okay, then, so the producer surplus for, you can put BRB for base road bar, would be equal to a P times Q. It's equal to the price we said is what? 50 minus 75, which is 60. And they're only selling one bottle, which equals, so their producer surplus is $60. Because they are willing to sell it for $15, but they don't have to sell it for $15 because the market price, according to the question, the market price is $75. So then, producer surplus for the rest of the market and that's equal to 1/2 base times height, because let's go back to our notes just to make sure. We go back to our notes to see A is the producer surplus for the base road bar. The rest of the market is B, which is also a triangle. And that triangle goes from 1 to 201. So this entire base then is 200, same as in the consumer surplus. So it's half the base times the height. The height is 75 minus 15, which is that 60. All right, so let's go back. Here's our question. Half base times the height. So the producer surplus is equal to 1/2 of base we said is 200 times the height we said is 60. So tab equal to 100 times 60, which equals 600. But that's not our answer, because what they're asking us for
100 times
is-
60 is 6,000.
Oh, I'm missing a zero. My apologies. Do not give away points like that. So total producer surplus, therefore, equals 60 plus 6,000, which equals to 6,060. Wait, what did I do wrong? No. Here. Question 18, it goes up here. Okay. Any issues with that? Now's the time. Can you do it again?
Mr. Demerit, so
Yes,
I
ma'am.
know you say if they were selling one bottle, right, of it. What if they
Yes.
was selling 2 bottles of it? Would we just times the 15 by 30 to get the 2 bottles? I mean, times the 15 by 2
If they
bottles?
was, no,
That's
if they were
for the-
selling 2 bottles, this is the producer surplus, right?
Yes.
So if they have the bottle, the wine's priced at 15, no, they're willing to accept $15. Because let's say that's what they bought the price, the wine for in the States, $15. But that wine in Nassau is selling for $75, right? So they would make $60 off each bottle. That's what you're asking, right? So you're saying if they were to sell 2 bottles, then the producer surplus would be 120. It'd be 60 times 2. Because remember now, if you look at here, the producer surplus for Base Road Bar for 1 bottle was $60. So for 2 bottles, it'll be 2 times 60, $120. I'm pretty sure I did not make that exam question that complicated. I didn't add any $2 or $3, 3 bottles to it. It's only 1 bottle. So that issue is not going to come up, at least, not for this class. All right. Okay, then. We did the costs. That just needs the price discrimination. That's the last one. All right.
Yeah, I want you to go over that last one for 30 points again, because I need that. I know you went over it, but
That's fine.
I just want you to do it again.
Okay. All right. So price discrimination. Rocky Farms Nursery has grown an abundance of poinsettia plants ahead of the Christmas season. All right. Actually, it's pronounced poinsettia, but we tend to leave off the settia. We just call it poinsettias. But anyway, Rocky Farms Nursery has grown an abundance of poinsettia plants ahead of the Christmas season and wants to be able to sell them not only in Nassau, but also in Miami. Right. So they end up with 2 markets for poinsettia plants, Nassau market and the Miami market. And each market has a different marginal revenue function and a different marginal cost function and a different price function, or what we call our inverse demand function. So you've given this information. And for question 1, can you calculate equilibrium quantity for Nassau, Q star for Nassau? Right. How do I go about doing this? Anyone wants to step in? What is the first thing we do? All right, shall we go to our notes? Let's see, I'll run out of time tomorrow night. All right, so let's see, notes. Cost, market structure, selling, upload pricing. Here, price discrimination. All right, so a steel producer in this case, steel. In our case, it was poinsettias. Oh, here's the operations right on the side here in this bracket. So what's the first thing they did? If you notice, they set marginal revenue equal to marginal cost. Isn't that what we've been saying for a very long time? That it doesn't matter the market structure. If you want to produce the optimal quantity, you produce, if you want to be at your most efficient, you produce where marginal revenue is equal to marginal cost. And that's what we have here in bold, in italicized. To optimize production, a firm must produce at a point at which marginal revenue is equal to marginal cost. So first thing we do, we set marginal revenue equals marginal cost. We solve it, yada, 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 and we come up with a Q star for the home market and a Q star for the foreign market. And then what we did, then we took that Q star and we plugged it into our inverse demand equations or our price equations to find out what the price is. So bear that in mind, let's go back to our question. So calculate equilibrium quantity, and they told us it's Q star, so it looks like it. So first thing we do is we set marginal revenue equal to marginal cost and solve for Q star. All right. So that's what we do. Shall we start with Nassau? Well, the question first asks us to start with Nassau. Okay, so marginal revenue for Nassau is what?
1,000 minus 10 Q.
1,000 minus 10 Q.
Is
And we
equal
said
to
equal to marginal cost is
380.
yes?
Mhm.
Set marginal revenue equal to marginal cost and solve for Q. Now, can we solve for Q looking at this?
Yes, we can. We just have to rewrite
Since we
the equation.
like our output to be positive, so why don't I take this negative 10Q and move it over to the right-hand side? So the 1,000 stays the same. I take the 380 and put, I'm lumping all the numbers together.
Mhm.
So that 380 becomes minus 380 because I move it over.
It's equal to 10 Q.
And the negative 10Q now becomes positive 10Q. Right. Okay, fine. What's 1,000 minus 380? That is
620.
620.
620.
All right, equals 10Q.
10 Q.
Therefore, 620
620 divided by
Divided
10.
by the 10 gave you 62.
that's my Q. So therefore, 62
is equal to Q
equals my
star.
Q star. All right. And that answers question 39. Question 40 then, calculate the equilibrium price for Nassau sales. What do I do?
Use the price equation.
I take that Q star and plug it into my price equation. Now, make sure I'm looking at the price equation for Nassau because that's what they're asking me about. Price equation for Nassau is P is equal to 268 minus 4Q. All right. All right. So price for Nassau is equal to 268 minus 4
times 62.
Thank you. 62. Because all I do is we plugged in 62 for Q. Because that's the Q we just found. All right. Fine. P therefore is equal to 268 minus what's 4 times 62?
248.
248.
248. Therefore, the price that we're going to charge for our poinsettias and Nassau would be
$20.
Isn't that work out nice and convenient? You're charging, it's still expensive. You're charging $20 a plant. Okay. Now, can we do the same for our Miami operations? Now that we
Yes,
know
we
how to
can.
go about doing it. So they're asking us to
Mr. Demary,
calculate.
you can go up a little bit. You could go up some more just for a second.
Of course.
Okay, thank you.
All right. So doing the same thing for the Miami operations, we said, first thing to define Q star, we need to set marginal revenue equal to marginal cost and solve for Q star. Oops, backspace star. All right. But this is the Miami Q star we solving for, right? Because we already solved star. All right. So we need the Miami marginal revenue. The Miami marginal revenue is
925.
925 minus 12Q. All right. So it's 925 minus 12Q. And what's
Is equal to
the
400.
that's the Miami marginal cost?
Mhm.
Okay. All right. So we do the same thing. Scroll down so we can see what's going on. All right, so we need 925, let's leave that where it is. Bring the 400 over, so that becomes minus 400. And move the 12Q over and becomes positive 12Q, right?
Mhm.
And what's 925 minus 400?
525.
525 equals 12Q. So 525 divided by 12.
Mhm.
43.75.
Equals Q. Sorry, you said it's 43.
What?
No, it's not dollars.
75.
43.75. Do not round this, please. Because I know you're thinking, oh, it's 3/4 of a unit, so I just round it to 44. Do not do that. All right, so that's our Q star. And that's good enough, because that's our Q star. There's no arguing with that. I'm supposed to be highlighting the answers there. Okay, fine. All right. And question 42 then says, right, what price we're charging for our Miami sales of poinsettias? All right. So what do I do?
Use our price equation for Miami and plug in our Q.
So what's our Miami price equation?
150 minus 3Q.
150 minus 3Q. All right. So P therefore is equal to 150 minus 3 times 43.75. All right. So P is equal to 150. What's 3 times 43.75?
131.25.
131.25. So therefore P is equal to what?
1875.
$18.75. So we can charge our Nassau people $20, but for our Miami people, we can't charge more than $18.75. Okay. Any questions before we go back to our simple model of the firm?
Mhm. Pretty
Okay.
simple.
And I will email you, everybody, this when we're done. Okay. So let's start from the top as if we hadn't done anything. So the We Sleep Fine Mattress Company is seeking to better understand and evaluate demand for its high-end premium mattresses and box springs. It is determined that the following demand and cost functions are applicable to its mattress sales. Right, so this is the information you're given, and you're given a demand function, QD equals 125 minus 0.25p, and a cost function is equal to 250 plus 50Q. Right, that's what you're given. You're tasked with producing the following analysis for use of the company. First things first, they're asking you find the inverse demand equation, also known as the price equation. So to do that, we said it's an inverse demand equation, so you invert your demand equation. So you start with your demand equation, and in essence, switch around the P's and the Q's so that your equation should end up with P is equal to yada, 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 yada. All right. So we start off with our demand equation. 125 minus 0.25 P. And since we need P, we took the 0.25 P, or is it 0.025 P? No, it's 0.25 P. So I take that 0.25 and I move it to the left-hand side. And that becomes positive 0.25. I know I need the P on the left-hand side, and I would need the P by itself, so I move the P over. I take the Q and put it on the other side. When it was on the left-hand side, it was a positive 1Q, but we generally do not put in the number 1 in front of a number like a letter like that. If it's positive, we just assume the 1. But when you move it to the other side and it becomes negative, we have to show that it's negative 1Q. Don't ask me why, that's just the way math works. Fine. So we end up with 0.25 P because we move it to the left, equals 125, that didn't change. And the Q, we move over to the right and becomes negative 1Q. So we end up at 0.25 equals 125 minus 1Q. But if we don't want 0.25 P, we want P by itself. So to get rid of the 0.25, we have to divide 0.25 P divided by 0.25. That allows us to cancel out the two 0.25s and leaves us with P by itself. But whatever we do on the left-hand side, we also have to do on the right-hand side because the equation says this is an equality. The two sides are equal. So on the left-hand side, that's 0.25 P, we divided that by 0.25. Then each element on the right-hand side, we also have to divide by 0.25. So we divide the 125 by 0.25 and the 1Q by 0.25. So 125 divided by 0.25 is 500. Double check it with a calculator, but I strongly urge you to always use your calculator for any quantitative issues in this exam, just to make sure. Even if you think you know it in your head, use your calculator just in case. And 1 divided by 0.25 is 4. So we end up with P equals 500 minus 4Q. So we know this is our inverse demand equation, also known as our price equation. Then they ask us to find the revenue equation. The revenue equation we know is price times quantity. Well, we just found a price equation. The price equation was 500 minus 4Q. And we multiply that according to our formula. Revenue equation is revenue equals the price equation times Q. The price equation is 500 minus 4Q. And he said we multiply that by Q. Right? Which means that we have to multiply not just the 4Q by Q, we have to multiply everything in our price equation by Q. The 500 has to be multiplied by Q, which gives us 500Q, and the 4Q has to be multiplied by Q, which gives us 4Q squared. We end up with a revenue equation that looks like 500Q minus 4Q squared. Then they want us to find marginal revenue. Now, this is a little more tricky because it means that we need to use our rules of differentiation or derivation, right? Marginal revenue, the rules of differentiation or derivation says that if you're looking to find the marginal revenue, or what we call the slope of a function, marginal revenue is the slope of the revenue function. Marginal profit is the slope of the profit function. Marginal cost is the slope of the cost function. Marginal anything is the slope of that function. So marginal revenue is the slope of the revenue function. To find the slope, we need to use our 4 rules of derivation. The first rule says, if you have in your original function a number that's just sitting it by itself, what we call a constant, a number that's not attached to any letter. There's no letter in front of it, there's no letter behind it. Right? It's just a number. In that case, we're trying to find the slope or the change of that number, and the slope of a number is 0 because a number cannot change from what it is. If it changes to something else, it's a different number. If you add 1 to 500, it has changed, but it's no longer 500, it's 501. If you divide it by 2, it's no longer 500, it's now 250. A number cannot change from what it is. Right? So the slope of a number is 0. That's the first rule. First rule says if you have a function with a number in it all by itself, the slope of the function with respect to that number is 0. Well, we don't have any number like that in our revenue function. Here's our revenue function. We don't have any number sitting out there by itself. So rule number 1 doesn't apply when we're trying to find the marginal revenue or the slope of our revenue function. Rule number 1 doesn't apply because we don't have any constant or any number sitting out there all by itself. Rule number 2 says that if you have a constant in front of a variable or a number in front of a letter, if you want to find the slope of that function with respect to that particular piece, the slope is just that number. So if you have a function that has 10x in it, then the slope of that function with respect to that number is just 10. If you have 15y, the slope is just 15. If you have 20q, the slope is just 20. In our case, we have 500q, so the slope is just 500. So rule number 2 says that if you have in your function something that has a number in front of a letter, a constant in front of a variable, the slope of the function with respect to that piece is just the number. So we do have something like that in our revenue equation. We have 500q. So it says if we try to find the marginal revenue or the slope of that revenue function, when we deal with that 500q piece of it, it's just 500. Then rule number 3 then says that if you have in your function some variable, some letter raised to a power, it'd be raised to the power 2, raised to the power 3 or 5 or whatever it is, it could be raised to the power of a half. But whatever it is, if it's raised to some power, this is how you deal with it. Rule number 2 says, if you have in your function a piece where you have a letter that's raised to some power, in our case, we have a q squared. Rule number 3 says you bring that power down. So you put that power in front. Like how we have here, we brought the 2 down. We bring that power in front, and then you subtract 1 unit from the original power. So we brought the power down, we brought the 2 in front, and then we said we subtract 1 from the original power. So we subtract 1 from our 2. So then, to deal with the 500q part of it, it's just 500. That's the second rule. To deal with the 4q part of it, we end up at 2 times 4 to the q to the 2 minus 1. 2 times 4 is 8. 2 minus 1 is 1. Anything raised to the power of 1 is itself. 2 raised to the power of 1 is 2. 2 raised to the power of 2 is 2 times 2 is 4. 2 raised to the power of 3, or 2 cubed, is 2 times 2 times 2, which is 8. All right. So anything raised to the power of 1 is itself. So in that case, Q 2 minus 1 is Q to the 1, which is just Q. So we end up with 500. That 500Q becomes 500. The 4Q squared becomes 8Q. And we, of course, are mindful of our negative signs. So we end up with a marginal revenue equation of 500 minus 8Q. If you have some concerns, you have the opportunity, now that we're virtual, to have the rules in front of you to work with them.
Mr. Demerit, so
Yes, ma'am.
say that had been 4Q to the power of 2, I guess minus 0 or minus another number. Would it
No,
still
no,
be
no.
like a 8Q to the top?
So let's say this is 4Q to the minus 4. Mean something like that?
Yeah,
In that case, you do the same thing. You bring down the power, and this will be, you bring down the 4 this time. And it would be up here, would be 4 minus 1. You subtract 1 from the original power. And that will be 4 times 4 is what? 16. And it will be 4 minus 1 is 3. So this will be Q to the 3, but it has to be to the power. So it'll be font superscript. And you end up at that. You do, the rule says you bring down the power. So you brought down the 4 and you subtract 1 from the original power. 4 minus 1, that's how we got to 3. 4 times 4 is 16. 4 minus 1 is 3. Follow?
yeah, okay.
Let me erase that. And so we get back to our original work. Okay. And we do the same thing for our cost equation because they're asking us for marginal cost. But our cost equation, you see, we have one of those numbers sitting on it all by itself that rule number 1 talks about. And rule number 1 says if you have a number sitting out here all by itself, the slope with respect to that number is 0 because 250 can't change. Rule number 2 says if you have a number in front of a letter, the slope is just the number. So we end with marginal cost equal to 50. Or simply by following the rules. Now, then they're asking us to find profit. Profit we know is revenue minus cost. Now, we have a revenue equation, 500Q minus 4Q, and we have a cost equation, 250 plus 50Q. So we just plug in those 2 equations, 500Q minus 4Q squared, that's our revenue equation. And our cost equation is revenue minus cost. So our cost equation is 250 plus 50Q. Here's my revenue equation. Here's my cost equation, revenue minus cost. Now I have to remove my brackets and simplify this equation. You can't just leave it as that. Right? That's not going to get you any marks. Right? So to remove the brackets, 500Q minus 4Q squared. Now this negative sign says that everything after it is going to change its sign from whatever it is to its opposite value. So this is a plus 250, now becomes minus 250. This is a plus 50Q, now it becomes minus 50Q. And again, you cannot leave it like this. You still have to simplify it because you always have to bring it to its simplest form, which means collecting things that are the same. I have a 500Q here and a 50Q. So I can collect those, but my 500Q is positive and my 50Q is negative. I end up with a positive 450Q. I only have one Q squared, when I say one Q squared, only one set of Q squareds. All right, so I keep my negative 4Q squared, and I only have one number sitting out here by itself, so I bring down my negative 250. And that gives me my profit equation. 450Q minus 4Q squared minus 250. Now they ask us to find marginal profit. So we have to go back to our rules again, because remember now, whenever we try to find the marginal anything, we need to use our rules. Now, we have a number in front of a letter. That sounds like rule number 2. Right? And rule number 2 says if you have a number in front of a letter, the slope of that function with respect to that particular piece is just the number. So 450Q becomes 450. That was rule number 2. Rule number 3, we looked at when we were just looking at the marginal revenue side of it. We said when you have a variable or a letter raised to some power, what do? You bring down the power. So we brought down to 2, and you subtract 1 unit from the original power. So we subtract 1, so we end up with 2 minus 1, which gives us 1. So we end up with 2 times 4, that gives us 8. And 2 minus 1 is 1. Anything raised to the power of 1 is itself. So we end up with 8Q. Rule number 1, because we still have to deal with the 250. Rule number 1 says if you have a number or a constant sitting out there all by itself, the slope of that constant is 0. Hence the 0. Well, whether it's positive or negative, doesn't matter. 0 is going to fall away. So we end up with a marginal profit equal to 450 minus 8Q. Rule number 2, rule number 3, rule number 1. So now we have all these equations that they're asking us for. They said, in addition, they want us to determine the quantity of output that should maximize revenue. And revenue is maximized. One of those things we need to keep in the back of our minds, revenue is maximized at a point at which marginal revenue is equal to 0. Profit is maximized at a point where marginal profit is equal to 0. Cost is minimized at a point where marginal cost is equal to 0. Right? So here, one quick diversion. Here is our class notes. I went too far, I didn't go far enough. Right. Here's our profit from our profit curve. We said marginal profit is equal to a point where the top marginal profit equal to 0 is a point where our profit is maximized. Right? Same thing for the revenue. We're trying to find the top of the revenue curve. Here's our revenue curve. Maximum revenue will be at the top of that curve, and that's where the slope, marginal revenue, is equal to 0. Right. If we were to draw the profit function, it'd be upside down. Okay, so how do we do that? We said to determine the quantity of output that will maximize revenue, we said is maximized at the point at which marginal revenue is equal to 0. Well, we know what our marginal revenue function is because we derived that earlier, and our marginal revenue function we derived to be 500 minus 8Q. So once we have that marginal revenue function, we know that revenue is maximized at a point at which marginal revenue is equal to 0. So if that's the case, if marginal revenue is supposed to be equal to 0, let's set it equal to 0. And that's where we plugged in the 0 marginal revenue. So instead of marginal revenue equals 500 minus 8Q, we said 0 equals 500 minus 8Q because revenue is maximized at a point at which marginal revenue is equal to 0. A lot of students, when they plug in that 0 there, then they throw up their hands and they don't know what to do next because that 0 throws them off. What do I do? Well, if you pretend that 0 was like any ordinary regular number, because it is a regular ordinary number, it just happened to be a 0, you wouldn't have any problem solving this. If this was a 10, or in this case 100, you would know exactly what to do. You said, oh, well, I would collect my numbers and solve for my Q. Well, you do exactly the same thing. It's just this number happened to be 0. Collect your numbers and solve for your Q. Well, since we know output should be a positive value, we would take the negative 8Q, move it over, right, and take the 0 and put it on the other side, and that would come minus 0, but we know whether it's positive or negative, 0 is still 0. So anyway, 8Q equals 500 minus 0. We move the 8Q over to the left-hand side to make it positive, and we make the 0, we move the 0 to the right-hand side to make it negative. But we could just ignore the 0, but I wanted you to see the operations. So in essence, we would have, if that was a regular number besides 0, we'd have moved it over to the right-hand side, and it would become a negative value. Moving the 0 over to the right-hand side also becomes a negative value, but since it's 0, it falls away. So we end up with 8Q equals 500. Q equals 500 divided by 8, which gives us a Q of 62.5. Do not round it, please. So we know that our revenue is maximized when we produce 62.5 units, or 62.5 cases, 62.5 runs, pallets, whatever the 62.5 is. We know revenue is maximized when we produce 62.5 units. Question 50 then asks us then, what is the maximum revenue that the firm will earn if it were to produce this amount that you just said they should produce? They want to know what the maximum revenue is. We said maximum revenue is attained when marginal revenue is equal to 0. So now that tells us how much we want to produce. Now that we know how much we're supposed to produce, we should take that amount and stick it into our revenue equation, and that will tell us how much money we will actually make if we were to produce that amount. So we take our revenue equation, 500Q minus 4Q squared, and wherever we see Q, because we know Q is supposed to be 62.5, wherever we see Q, we stick in 62.5. So we end up with 500 minus 62.5, sorry, 500 times 62.5 minus 4 times 62.5 squared. Always solve your brackets first. I'm assuming you know that by now. So you would not multiply 4 by 62.5 and then try and square it. You solve your brackets first. So you do the 62.5 squared first. So 500 times 62.5, we found it was 31,250. And to get to do the square part of it, 62.5 times 62.5 is presumably 3906.25. So we end up with 31,250 minus 4 times 3906.25. And assuming y'all gave me the right answer, 4 times 3906.25 is 15,625. And when we subtract that from 31,250, we get exactly 15,625. So we use our marginal revenue equation to find out the optimal level of production, that Q. And then once we figure out how much we're going to produce, we plug that into our revenue equation to tell us what our revenue would be if we would produce that amount. Then they asked us about profit side of it. We know what we should produce if we were going to maximize our revenue, but what about when I should maximize our revenue? What if we wanted to maximize our profits? Because that's what the question is asking us. Then we do the same rationale to determine the quantity of output that will maximize our profit. We set marginal profit equal to 0 and solve. So what do we have here? Oh, oops. Let me copy this. Oh, what use away. Copy this and here and paste. Okay, and we have here profits. Profit is maximized at the point at which marginal profit, not marginal revenue, let's insert a symbol. All right. So we know that profit is maximized at the point at which marginal profit is equal to 0. Now we scroll back up and find our marginal profit equation that we derived was 450 minus 8Q. All right. We know that because we just figured that out a few steps earlier. So now we have our marginal profit, and it says, we remember from our notes that marginal profit is maximized at a point at which marginal profit is equal to 0. So if marginal profit is equal to 0, let's make it equal to 0. So we plug in 0 for marginal profit, and we end up with 0 equals 450 minus 8Q. And we hold on to our lunch and don't get too wigged out about that 0. And we remind ourselves, it's just a number. It's just a number. It's just a number. So what do I do if it's just a number? Well, I collect my numbers. I take the 8Q and I put it on the other side and become positive 8Q. I take that 0 and bring it over, it becomes minus 0, but anything minus 0 or positive 0 is still nothing, 0. So I can eliminate that and I end up with 8Q equals 450. If 8Q is 450, then Q, the quantity of output at which my profit will be maximized, would be 450 divided by 8, or 56 1/4. Do not round that, please. So Q equals 56 1/4 units. So we know if we produce 56 1/4 units, our profits will be maximized. However, if we produce 62.5 units, our revenue will be maximized. But if we want to maximize profits, we need to reduce our output to 56 1/4 units. Now that we know how much we need to produce if we want to maximize our profits, they're asking us how much would that profit be if we would actually produce that amount. So to find out how much our profit would be if we would actually produce 56 1/4 units, we take our profit function, and wherever we see Q, we plug in 56 1/4. Our profit function that we derived earlier was 450Q. Now this is profit, not marginal profit now. So we make sure we get the right function. Our profit function is 450Q minus 4Q squared minus 250. So we know that we're producing 56 1/4 units. So we plug in 56.25 wherever there was a Q in our profit function. So we end up with 450 times 56.25 minus 4 times 56.25 squared minus 250. 450 times 56.25 assuming you guys did your calculations right, turned out to be 25,312.50. And we always solve our brackets first, so we need to do it 56.25 squared, which according to you guys is 3164.0625. At least you kept it to the 4 decimal places. Fine. And the negative 250 stays. So we have 4 times 3164.0625 becomes 12,656.25. So we end up with profit equals positive 25,312.50 minus 12,656.25 minus 250. Well, I have a minus 12,656.25 and a minus 250, so I can add those two negative numbers together, and they give me a negative value of 12,906.25. So I have a positive 25,312.50 and a minus 12,906.25. The end result is a profit of $12,406.25. Okay, so that's our profit when we were producing 56 1/4 units. And lastly, they said, okay, let's say we were to produce 56 1/4 units. What price should we charge to sell that entire 56 1/4 units? What price that should be charged in order to sell this amount? Well, to figure out what price we would charge, we need to go to our price equation or invoice demand equation that we produced way at the very beginning of this question. And that's why the equation is often called a price equation, because it allows us to determine the price that we should charge if we want to sell a certain amount. In this case, we know we want to sell 56 1/4 units. So we take our price equation is 500 minus 4Q, and we plug in 5625 where we saw the Q. So we end up P equals 500 minus 4 times 5625. 4 times 5625, you guys told me was 225 even. So 500 minus 225 is the price of our mattresses is now $275 each. And that, ladies, gives you 30% of your final exam grade.
Mr. Demerit, go back down 1 second, please.
Go down.
Let me see. How did you get the 3164? 3164, that's when you
Okay.
multiply.
5625 times 5625.
Oh,
I gave it a big number. And I want to make sure we take it to 4 decimal places just in case. It's like I've been telling you all along, do not round this nonsense. All right. Any rounding, you go all the way to the very last number. And you don't even have to round that. I'm happy if you give me 4 decimal places. Okay, so that's all I have, unless y'all guys have something else y'all want me to look at.
Mr. Mayor, you can send me the same.
I'll send it to everybody.
Okay, and what about you get our final grades or?
Yes, you'll get your, okay, this is what I'll do. I will, okay, I'll make it easy on myself and you guys. The exam is tomorrow. So I will send you your grade up to that point. So your homework and your midterm, the homeworks that you've done up to this point, plus your midterm. And I will send you your final grade, or your final exam grade, obviously. And those two together, you should be able to have a very clear idea of what your ultimate grade for the class is going to be, if that makes sense.
Okay, thank you.
Because I am not allowed to give you your final grade for the class. You have to collect that from the school. I certainly can give you what your grade is up to the point, all the work prior to the final exam. And I can give you the grade of your final exam grade. And you certainly you can put those two together. All right. Okay, so let me save this. Can I open my center by email? I can. Come on. Okay, here it is. And let's go with microeconomics for everybody. And this is called exam prep. No, mock final. All right, and please see attached. And let's attach that file. Make sure it has all the answers all the way. Enable editing. Okay, this is the right one. And let's go with. So see if it pops up in your emails before we call it a night.
Received. Thank you.
All
I
right.
got it too, thank you.
All right. So I'll see you guys tomorrow at 6. Remember, I will email the exam 5 minutes before 6. If you send it to me after 9, it will not be accepted. All right. All right, folks. You have a good evening.
You too, good night.
You too,
Okay,
good night.
night.